Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and native topics. If you find these videos helpful, please consider supporting me on PayPal, Patreon or Buy Me a Coffee. Links in the description box below. Today we're going to cover Mathematics in 6. The topic of this tutorial is a mixed bag of DP exam test questions. Round 5, question 5.4, centers of pressure. The question is included in the video. We have been asked to issue a cautionary note. When doing these questions, please use the method I'm going to show you, as this is the method that is marked correct. Using your own method to answer questions could cost you marks, even though your method and answer might be right. See the cautionary note at the beginning of the video. On a side note, watch until the end of the video. If you only watch the first 5 minutes, you will not gain a full understanding of what you need to do. There is no quick fix in mathematics. It takes persistence, discipline and repetition. You have to use these steps in order to succeed. Let's get straight into it. Our question states, a vertical retaining wall in a water canal is 6 meters wide at the top, 5 meters wide at the bottom and 2 meters high. The top of the retaining wall is 2 meters below the water surface. Sketch the retaining wall and show the representative strip you will use to calculate the depth of the center of pressure. Okay, so first thing we need to do is make our retaining wall. Okay, so how it goes is it is 5 meters wide at the bottom and 6 meters wide at the top. So if it's directly in half, it will be right here. It will be directly here. So now this is 2 meters. That's 2, and this. Now, because it's 6 meters across, it is 3 and 2. And this is because it's 5 at the bottom, it is 2,5 and 0. Because this is at the top. Now, our water line is up here at the top. Here's our water line. And that's at 4. And that is at 4. So, what we need to do now we need to find R. So R is this here minus Y. And Y is that. So, R equals 2 minus Y. Next, we need to calculate our gradient of this line here. Of this particular line over here, we need to find that gradient. So, M is equal to y2 minus y1 over x2 minus x1. Now, we can make it either or. So, y2 is 0. Minus 2 over x2, 2,5 minus 3 equals. Now, this is M. So, what we need to do now is say 0 minus 2 is minus 2. 2,5 minus 3 is minus a half. So minus a half over 2 over minus a half will be plus 4. So M is equal to 4. Now what we need to do is get our formula. So y minus y1 equals m times x minus x1. So let's do, bottom one makes it much easier. So y minus 0 equals m times x minus 2 comma 5. Okay, and m is equal to 4. So we're going to multiply 4 through. So y is equal to 4x minus 10. 2 comma 5 times 2 is 5, and 5 times 2 is 10. So that's how 2 comma 5 times 4 becomes 10. Now what we need to do is make x the subject of the formula. So we drop the 4, 1 over 4y plus 10 equals x. That is our formula. So now what we need to do is this. The integral, now this is taking the y coordinates, so 2 and 0, it is r times dA dy. So now to get dA equals 2 times x dy. So x is equal to this. So 2 times a quarter dA. 2 times a quarter is a half y, and 2 times 10 plus 20 dy, and r is 2 minus y. So we have our formula that we need. So what we're going to do now is say the integral 2 and 0, r is 2 minus y times a half y plus 20 dy. So now what we need to do is take 2 times a half. Let's multiply these in. We reverse FOIL. Yeah, we FOIL now. So now we take 2 times a half is 1. So the integral of 2 and 0. So it's 1y. 2 times 20 is plus 40. Y times that is minus a half y squared minus 20y. Alright, let's clean this up. 1y minus 20y. So this is the integral of 2 and 0 minus a half y squared minus 19y plus 40. So now we can integrate. Now we can integrate. So, integration minus a half y over 3 cubed minus 19 over 2 y squared plus 40y. And then it's 2 and 0. So we've integrated now. Everything is equals from this point onwards. So, minus a half times 2 cubed 2 times 3 is 6. So 1/6 minus 19 over 2 times 2 squared plus 40 times 2 minus 0. And that answer is area moment is equal to 40,667. So, area moment is equal to 40,667. Now, what we need to do is work out the second moment of area. The second moment of area looks like this. The integral of 2 and 0, 2 minus y squared times a half y plus 20. Alright, dy. So, first things first, is we need to FOIL out 2 minus y. 2 minus y times 2 minus y. So 2 times 2, 4. Minus 2y minus 2y plus y squared. So essentially what we are left with is the integral of 2 and 0, and we are left with y squared minus 4y plus 4. Bracket, a half y plus 20. Alright, so y squared times a half y, integrate. So this is a half y cubed plus 20y squared minus 2y squared minus 80y plus 2y plus 80. So, our sum will be a half y cubed plus 18y squared, that's done, minus 78y, that's done, plus 80. Alright. So next step is we can integrate. Next step is integration. So a half Now y over 4 to the power 4 plus 18 over 3y cubed minus 78y squared over 2 plus 80y. 2 and 0. Okay. Now we replace, we go a little bit further. This is 1 over 8 times 2 to the power 4 plus 6 times 2 to the power 3 minus 39 times 2 to the power 2 plus 80 times 2 minus 0. And this all equals 54. Now for our center of pressure, which is very simple. It is 54 over 40,667. And that comes out to 1,328 units. If you found this tutorial helpful, please give it a like and subscribe. It really helps with the algorithm and to grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comments section to let me know what topics you would like me to cover in upcoming videos. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.